Hi everyone, so this is Aarav Sinha here, and I'm going to be solving the 2022 FRQ question number 5. So let's go ahead and begin. So, question 5 says, figures 1 and 2 above illustrate regions in the first quadrant associated with the graphs of y equals 1 over x and y equals 1 over x squared, respectively. In figure 1, let R be the region bounded by the graph of y equals 1 over x, the x-axis, and the vertical lines x equals 1 and x equals 5. In figure 2, let W be the unbounded region between the graph of y equals 1 over x squared and the x-axis that lies to the right of the vertical line x equals 3. So we start with question set A. So let's go ahead and begin. Question A says, find the area of region R. Region R, as we see, is underneath the graph of y equals 1 over x from the x values of 1 to x equals 5. So we go ahead and we implement area is equal to the integral from 1 to 5 of 1 over x. 1 over x dx. Because we want the area of the graph, we want the area of this graph right here from, we want the area of the graph of y equals 1 over x from x equals 1 to x equals 5 from right here to right here. So we take the integral. So we go ahead and we solve, and we say area is equal to natural log absolute value x evaluated from the upper bound to the lower bound, 1 to 5 to 1. Area is equal to natural log 5 minus natural log 1, and natural log 1 just equals 0. So area of the region R is equal to natural log 5. Natural log 5 is the final answer for part A. Now, let's move on to part B. Region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with area given by x e to the x over 5. Find the volume of the solid. So, to start this question, we must realize that volume is equal to the integral of area. This is a Calc AB topic, so we should be familiar with this. And so for this question, when it says region R is the base of a solid, for a solid at each x, the cross-section perpendicular to the x-axis is a rectangle with area, we realize that to find the volume, all we need to do is take the integral from, and this is region R, so we go, and region R is from 1 to 5, so we go that this volume is equal to the integral from 1 to 5 of x e to the x over 5, which is the area that was given to us, dx, because volume is equal to the integral of area. So now, we now begin to solve. And the technique to solve this integral is integration by parts. So our u is x, our dv, and dv, our dv is e to the x over 5, which goes to 5 e to the x over 5. Let me just move this out of the way. And so now, and our du is 1. So now we can correctly do integration by parts to get volume equals 5 x e to the x over 5 minus the integral of u So 5e to the x over 5 times 1. So it's the integral of 5e to the x over 5 dx. 1 to 5. And all we have to do here, we evaluate this from 1 to 5 as well. So volume is equal to 5 times 5 e to the 1 minus 5 e to the 1/5 minus 25 e to the x over 5 from 1 to 5. And we should end up with 25e minus 5e to the 1/5 minus 25e to the first power minus 25e to the 1/5. So volume is equal to 25e minus 5e to the 1/5 minus 25e plus 25e to the 1/5. And so 25e and 25e, these two cancel out. And 25e to the 5th minus 5e to the 5th just results in 20e to the 1 over 5. So now we found the volume of this figure right here. Volume is equal to 20e to the 1/5 power using integration by parts. Some common mistakes here is that you don't do integration by parts correctly. You mess up the u, you mess up the v. So make sure you pay attention to this step right here. Another common mistake is not distributing the powers properly together. Another thing that you can make a mistake on is, for example, you incorrectly solve this integral, this 5e to the x over 5. So make sure you keep in mind that there's a u sub involved in this step right here. And I just passed over that part, but just make sure when you do it, also right here, I passed over right here, that there's a u sub involved. You're supposed to u sub x over 5 as u 1/5 dx equals du, and so on. So just keep in mind that these u subs are happening at the same time while you solve this problem. Okay, so now let's move on to part C, the last and final question. So it says, find the volume of the solid generated when the unbounded region W is revolved about the x-axis. So W is, we see the area under the graph of 1 over x squared from x equals 3 unbounded. So we don't know, this has no bound, so essentially it goes to infinity. We would solve this question by, so first it says revolved. Now when something is revolved, we essentially, what we do is we do the method we learned in Calc AB, where if you rotate something around, we learned that the volume of something rotated around the x-axis is pi times the, so this volume would be, essentially it draws on the volume of a cylinder, which is volume equals pi r squared. So it's the same principle here. The volume of this solid generated is equal to limit as t approaches infinity from 3 to t of 1 over x squared times, forgot the pi out front, sorry. Make sure, this is a very key thing that a lot of people miss. Like for example, I just missed it here. This pi right here, you can write it over here, or you can write it over here. It doesn't really matter. I'll just change that. So I'll write it. Volume as limit t approaches infinity from pi. Make sure you don't forget this pi, because this pi is very important. And if you forget this, results in it's a very common mistake, so you don't want to forget that. Volume is equal to limit as t approaches infinity from pi from 3 to t, 1 over x to the 4th dx. And so volume is equal to limit as t approaches infinity from pi 3 to t of x to the negative 4 dx. And volume is equal to limit as t approaches infinity pi from. So then we solve this integral and we get negative 1/3 x to the negative 3 evaluated from 3 to t. So volume equals limit as t approaches infinity pi times this negative 1/3 over t cubed plus, because there's a negative at the negative 1/3, don't forget that, 1 over 3 times 3 cubed. And volume equals limit as t approaches infinity of negative pi over 3t cubed plus pi over 3 to the 4th. And so since its limit as t approaches infinity, this goes to 0. And we are left with volume equals pi over 81. Final answer right here. So now we have our volume, and we know this because we know that we have this answer because we found the volume as this solid, this region W was rotated, revolved about the x-axis. So we used our pi r squared. And we also, one thing to make sure is that you pay attention to the limit as t approaches infinity because it is improper notation. You go from 3 to t. And the last thing was not to make a mistake on this step right here and this step right here, because this is a very important step where mistakes can be made. But yes, that is all. Thank you so much.